Lesson 1-7, Functions. Our essential question is, how do you evaluate an equation written in function notation? We have two equations that are written in function notation. Remember, function notation is when you have a letter like f of x. That's how you read this first function. You say f of x equals 4x squared. So it's a function in terms of x, where x is our independent variable. So we're going to plug something in for x and then evaluate that function. When you're working with more than one function, usually you're going to see different letters. So we have two functions, one f of x and the other g of x. And there's no rhyme or reason about which letters are used. It's just pretty typical that you see f for function used most commonly. So the first one to evaluate says f of 2. So if you compare the f of x to the f of 2, what I'm hoping you can visualize is that where the x was in the function notation, it was replaced with the letter 2, or the number 2, sorry. So the letter x was replaced with the number 2, so then on the other side of our equation, we need to do that same thing. Replace the other letter x with a 2, and then evaluate it using the order of operations. 2 squared is 4. So 4 times 4 is 16. So f of 2 is equal to 16. My next one says f of negative 4. So now I'm going to replace the x with the negative 4 instead. Following the order of operations, negative 4 squared is 16. So 4 times 16 is 64. Now, switching to our other function, g of x equals 2x plus 7. G of negative 3, if I replace the x with the negative 3, so here the x turned into negative 3. So over here, do the same thing. Use the order of operations. 2 times negative 3 is negative 6. Negative 6 plus 7 is 1. And then the last one, g of 5. So now replace the x with a 5. 2 times 5 is 10. 10 plus 7 is 17. So these are the basics. These examples here, where we're plugging in just a number, a positive or negative number, these are the basics with function notation. So hopefully everybody's with me so far. Now what you see is these problems are getting a little bit harder. We'll look at one at a time here. So f of x equals 3x plus 2. And what I'm substituting in for the x is m plus 5. So there's still a variable there. So if I replace the x with m plus 5 on one side, I have to do that on the other side, and that means keeping it in parentheses, because the x right here was being multiplied by 3. So the entire thing that I'm plugging in has to get multiplied by that 3. So distribute the 3. 3 times m plus 3 times 5 would be 3m plus 15. Then combine your like terms. The 15 is a positive, the 2 is also a positive. Combine those together because they're like terms, and you get 3m plus 17. The next one, we're using g of x this time. So g of x equals 2x minus 1 is our function to start with. And I am substituting for x t plus 1. T plus 1. So where the x's are, I substitute t plus 1. So this x here and this x here, and keep it in parentheses. Now distribute. 2 times t is 2t, plus 2 times 1 is 2, and then minus 1. Combine the like terms. Positive 2 combined with negative 1 is going to give us 2t plus 1. And the last one, staying with g of x. So g of x equals 2x minus 1. And I'm substituting now p minus 2. So p minus 2 for each of my x's. Distribute. So 2 times p minus 2 times 2. And then on this one, my like terms, they are both negatives. So if I combine negative 4 and negative 1, I get negative 5. 2p minus 5. So these are the trickier ones with function notation. A little bit more to it. Hopefully not bad though. Now we have a click and drag. So look for the correct answer, plug it in, solve it, find the correct answer, and drag it over. So if I substitute negative 2, in the first one, negative 2 squared is 4, times 3 is 12, plus 4 is 16. The next one, substitute 8. Negative 5 times 8 is negative 40. Negative 40 plus 2, negative 38. Substitute 1. 1 times 12 is 12. 8 minus 12 is negative 4. Substitute 5. 5 squared is 25. Minus 5 is 20. Negative 15 plus 8 is negative 7. And 2 to the third power, 2 times 2 is 4, times 2 is 8. 8 minus 4 is 4. Now we have a click and drag to review whether something is a function or not a function. So I'm going to start with graphs. Not a function. It fails the vertical line test. This one passes the vertical line test. Fails the vertical line test. Passes the vertical line test. Fails the vertical line test. Done with the graphs. Now I'm going to look at the tables. I remember that if the domain repeats in the table, it is not a function. So the domain repeats, not a function. Domain does not repeat, so that one's good. And the domain does not repeat on this one. Nope, so that one's good. Now on the mapping, this one has nothing repeating in the domain because each domain has just one ray going from it. This one, the positive 2 has 2 rays off of it. And this one, the positive 4, has 2 rays off of it. So those fail. This one looks good. And then the ordered pairs. This one's got 2 5s for x. This one's got all different values for x. So there are my functions, then not a function. All right, you should be able to write a summary now. To evaluate an equation written in function notation, please describe in complete sentences how you do this.